Hello, let's continue our Sudoku adventure with Red Lines and Circles by Emphyrio. I don't know why it's called Red Lines and Circles. I'm wondering if there was a title mishap here, but we're just moving forward with it. So we do have normal 6x6 Sudoku rules. So in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these killer cages in the grid. These are these cells surrounded by dotted lines. The digits in a cage sum to the value in the top left. So these two sum to 8. So they could be, for example, a 3 and a 5. All right. 3 plus 5 is 8. Could be 2 plus 6, whatever. We also have these, he calls them teal lines in the grid. They're the only lines. So they're kind of like palindromes, except one side is consistently 1 greater than the other side. We don't know which side's greater than the other. That's for us to figure out. But basically, we take the cells that are equidistant from the center, these two cells, for example, and these two cells, and one of them will be 1 bigger than the other, but we're consistent about it. So if this were, for example, 3, 4, that would mean this side is consistently 1 greater than this side. So if this were, say, a 2, this would have to be bigger, be a 3. It would not be a 1. This does not work because this is not consistently larger than that side. So this could be a 3, right? If this were a 2, forgetting the fact that we're repeating in the box, then this could be a 1. This would have to be a 1, because now this side would be bigger than that side. For odd length lines, the middle digit just isn't affected by anything. It can be whatever it wants. And you can repeat digits on the lines as long as other rules allow you to. So basically, there's no extra non-repeat restriction at all. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay, so the 10 cage is a good place to start, because the only way to add to 10 is 4 plus 6. So we can pencil 4, 6 in there. I'm seeing a couple things. So first, we're going to start with these shift lines. We know that these digits are consecutive. We don't know what order, but we do know they're consecutive. So the 6 would always go with a 5, and the 4 would have to go with a 3 or a 5. Same thing with this, and luckily that does make this a 3-5 pair, which will add to 8, and that makes this a 4-6 pair, which adds to 10. So that works out. These two cells here need to be consecutive. Now, a nice little way to kind of think about consecutive digits to help you narrow down options quickly in your head is that there's always one even and one odd in a set of consecutive digits, because that's just how even odd works. They switch, right? Odd, even, odd, even, odd, even. So there's going to be one even, one odd in 2 consecutive digits. And we have 2 of our odd numbers gone. 3 and 5 are gone. So this has to have a 1 on it, and that's going to join a 2. We don't know what order they go in, but it's going to match the order of these. Oh, no. Oh, no. Okay, and so that leaves a 4-6 pair here. She's very unhappy right now. Okay. Oh, and that makes some 4-6 pair here and a 4-6 pair here. That removes 4-6 from all of these cells. And so in this box, this is a 4-6 pair. This 3-5 pair looks up, making this a 3-5 pair. And that leaves the 1 and the 2 for here. Okay, and now we can talk about this and this here. So always be suspicious when you have 2 dominoes like this, where one's in this row and one's in this row, or similarly. 2 different rows of the same band in a 6x6, because bands are always I know she doesn't like this explanation. Bands are always roped, so the same 3 digits here are going to end up here because they got to go in this box somewhere. And so we need a 4 and a 6 to go up here. Well, the 4 isn't going to end up in the 8 cage, because then we'd have to put another 4 in the 8 cage to add to 8. So this ends up being a 4, and that puts a 6 in the 8 cage. And with the 6, we need a 2 to add to 8. And so this ends up being 2, and this is 1. And so this is 1, 3, 5. Okay. So again, consecutive digits. One's going to be even, one's going to be odd. This is odd. So this is definitely going to be even. It has to be 2 or 6, because the 4 looks down. This could still be 1, 3, or 5, though. All right. Now, how about 2, 6 to this 8? Well, this is even, so this is going to be odd. And so this is going to be 3, 5 again. And so that makes this a 1. These are not 1s. It makes this a 2, 6. Okay. What do we do with all this? 2, 6 to 3, 5. Yeah, because this cage is even, so this cage is going to be odd. So there's only 2 ways to add to 8, 2 even numbers or 2 odd numbers. So this 3, 5 is going to do the same thing here, where we need an odd digit on here. So this is going to be 1, 2, and then this is going to be 4, 6. Interesting. Okay. So how do we move forward from here? It's not obvious to me. I bet these are connected in an interesting way. If this were a 6, that would make this a 4, and that would force this to be 6. So this would be the larger side, it would be 6, 2. If this was 2, this would be 1, and this would be 2, and that would still make this the larger side. Does that mean this is always the larger side? 6, 2, 1, 5, 6, 2. Wait, that doesn't... Hold on, did I do that wrong? If this is 2, this is 1, and that's 2. I think that means 4, 1 doesn't work here. Let's look at what that does. If this is 4, and this is 1, that makes this a 2. Oh, wait, but then... Yeah, that breaks this cell. Okay, so if this is 6, and this is 2, then this is 1, and this is 5. That's is 4, and 3, and 4, and 6. And now this has no value. Did I make a mistake somewhere? Like, is there some other way to do some of this that I didn't notice? I don't get what I did wrong here. We had the 4, 6, gave the 3, 5. This has to be 1, 2 because it needs an odd number. These are consecutive. Makes this a 4, 6, makes that a 4, 6. This is 1, 2. The 4 ends up here. Is it this 2? Oh. Huh? No, this 2, 6 does affect this 3, 5. This 2, 6 goes to this 3, 5. This 2, 6 goes to this 3, 5. 3, 5. These are consecutive. Huh. I don't know how to not break this. Is there... Oh, okay. Right. Sorry. I thought that if this was the larger side, this had to always be a 6. But this could still be a 4 if this was the larger side. And that would make this a 3. So I missed a case, right? So I think this can't ever be 6. Because if this is 6, it makes... I don't know the good way to put this. I think this is the best way to put it, is whatever this 2, 6 is, right? So if this is a 2, this ends up a 1, making this the smaller side, definitely. If this is a 6, this is 4, and this is 6, making this the larger side, and this is still the smaller side. No matter what this 2, 6 is, this is the smaller side, and this is the larger side. That at least makes this a 1 and this a 2, which makes this a 6 and this a 2, making this a 4, this is a 6, and that makes this 4 and 6. And there we go. That actually works out. This is 5, this is 3. Phew, okay, I thought I'd made a mistake somewhere. There is a 3 in the corner, deet deet dooting, celebrating the fact that we figured this out. 2 has to go with 3 here, that's a 5. We can just fill out these. This is a 1, 3 pair, we actually know the order. This is 1, this is 3. A little slower one-handed here, but that's alright. That 1 gives us the 2 and the 1, giving us the 6 and the 2. 2 has to go with 3, 6 has to go with 5. That's our 4, that's our 6, giving us the 6 and the 4. Down here, we need the 4, 5. That's 4. That's 5. Okay, the 4 digits here, we need a 1. That ends up here. That finishes the row with a 5, giving us the 3 and the 5 here. And then the 2 digits up here, we have the 2 and we have the 3, and we're done. Alrighty. Yeah, that last little bit there was a little fiddly, and I missed a case, because I assumed if this was the big side, it would make them both a bigger number, but that wasn't true, and that's where I got kind of stuck. I wonder if there was a more, like a cleaner way to see that this could never be 6. There were a lot of ways to prove this couldn't be 6, but it all had to do with breaking this box. Pretty interesting. All right, well, let me know how you did, and if you enjoyed it, why not leave a like, subscribe, and a kind comment below.